Hi guys, welcome to a new video on differentiation under Math SL. This is our first review video on differentiation and I have classified them by difficulty level. So this is the easiest video in the review series. I shall tackle the 4 questions on the screen in front of you and I shall begin question 1 shortly. So, question 1 came in paper 2, May 2018, time zone 1, question 1. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So, you are given the function ln x minus 5x, and you are asked to find f dash of x in question A, so this is simple differentiation. And the answer is 1 over x minus 5. Next, you are asked to find f double dash of x, which is found by differentiating this green function right there. And this gives you negative 1 over x squared. Finally, you are asked to solve f dash of x equals f double dash of x, which you can do either manually or using the GDC. So I've done a bit of it manually. These are nice techniques for you to know. So 1 over x minus 5 equals negative 1 over x squared. I shall multiply the entire equation by x squared in order to get rid of all the denominators. So, excuse me, first I got the 1 over x squared to the left hand side so that all my terms are on one side. Then I multiplied by x squared for the 3 terms. So 1 over x times x squared gave me x, negative 5 times x squared gave me negative 5x squared, 1 over x squared times x squared gave me 1. Finally, I can solve this purple equation either using the quadratic formula or the GDC. Let's check how to do this using the GDC. So I've written down my equation on the GDC. Next I shall click on trace, and the GDC tells me that I have 2 zeros, 2 x-intercepts, right there and right there. Of course, you should know from the domain of the function that x is only greater than 0, so you should not even worry about the left x-intercept. You should not worry about this one. Your answer is the right x-intercept. So in order to find that, I shall click on second, trace 0. I shall provide a left bound, so somewhere to the left of my point, then somewhere to the right of my point, and then I shall guess where the point is, and the calculator tells me that x equals 0.558, which I have written right there. So this is your answer. Take a minute to copy this down if you will, and I shall begin the second question shortly. So the second question came in paper 1, November 2012, question number 4. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, we are required to find f dash of x. This is simply done by differentiating this function, which I've rewritten right there. So ax cubed becomes 3ax squared, negative 6x squared becomes negative 12x. As for question B, you are told that the graph of f has a gradient of 3 at the point P. Find the value of a. So at point P, the gradient is 3, hence m equals 3. Hence f dash equals 3, and we know that at P x equals 1. So when x equals 1, f dash equals 3. Or in other words, f dash of 1 equals 3. So I simply substitute 1 into f dash of x. So 3a times 1 squared minus 12 times 1, which I've written in green right there. And this gives me 3a minus 12, and I know that this is equal to 3 because the slope is 3. Hence 3a equals 15, and hence a equals to 5. So this concludes our second question. Kindly take a minute to write the answer down if you will, and I shall begin question 3 shortly. So the third question that we shall tackle came in paper 2, November 2001, time zone 1, question 7, triple I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, we are required to find dy by dx or y dash, given that y equals x sine x. So we shall use the product rule, u v dash, which is the derivative of the second term, so this is v dash, plus v u dash, so u dash is the derivative of the first term, and this gives us x cosine x plus sine x. Now in B we are asked to find the second derivative and show that it looks like this. So the second derivative is obtained by differentiating the first derivative, and to differentiate x cosine x I shall use the product rule again. So this is my u, which is the x, and my v, which is the cosine x. So there is u v dash, and there is the v and the u dash. Then finally I shall differentiate sine x, which gives me cosine x. After adding the like terms, I get negative x sine x plus 2 cosine x, which is what I was required to show in B. Next, I'm told that the graph has a point of inflection near x equals 1, and we know that at the point of inflection, y double dash equals to 0. We need to show that this equation must be satisfied. So we set y double dash to 0 and attempt to solve. We get negative x sine x plus 2 cosine x equals 0. I shall take this term to the right hand side and change the sign from negative to positive. Then, seeing that I want to show that x equals something, there is an x right there alone. So I want to isolate this x. So I shall divide both terms by sine x, which will help me because sine x in the numerator shall cancel sine x in the denominator, and I am left with x on one side. As for the other side, you should know that since tan x is sine x over cosine x, then cosine x over sine x gives me tan x in the denominator, or 1 over tan x. Hence, this term, 2 cosine x over sine x, is equivalent to 2 over tan x, because cosine over sine is the inverse of the tan function, so the tan is in the denominator. Hence 2 over tan x equals x. So take a minute to copy this down if you will, and I shall begin the fourth question shortly. So the fourth question came in paper 2, November 2011, question 10. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, you are given f of x equals 20x over e to the power of 0.3x, and you are given a specific domain, and you are asked to sketch the graph of f. So let's use the GDC to do that. So I've written down the equation of the function. Then I'm going to adjust my window. I've adjusted the x from 0 to 20 as per the given domain. As for the y, I've played around with it until I got a decent picture. So this is done by trial and error. Next, I shall click on trace, and there is my curve. So let's check out the marking scheme. So the drawing looks very similar to the marking scheme. You are given a mark for approximately correct shape with inflection, and by inflection or change of curvature we mean that it goes from a frown to a smile, and there is the point where the curvature changes roughly, so you had to copy this from the calculator. It had to have a change of curvature. Another mark for the fact that the maximum is skewed to the left, so it cannot be a regular bell shape. It has to have the maximum not in the middle but slightly leaning to the left. Finally, a mark for asymptotic behavior to the right, which means that the function cannot touch the x-axis. It has to approach it but not touch it, which is what we mean by asymptotic behavior. So let's move on to question B. We want the maximum point on the graph of f, the x-coordinate of the maximum point on the graph of f, as well as the interval where f is increasing. So let's check out the graph. So the maximum point is right there, and we find it by second trace maximum left bound, so somewhere to the left of my point, then somewhere to the right of my point, and finally a guess as to where the point is roughly. And the calculator tells me that the maximum is at x equals 3.333, and in order to find the interval where f is increasing, which is I can simply deduce that f is increasing from the beginning up to the maximum. So this is where f is increasing. After the maximum, the function shall be decreasing. Hence my interval is 0 less than or equal to x less than or equal to 3.333. Actually, just less than 3.333, because at 3.333 the slope is 0, so the function is neither increasing nor decreasing. Hence, these are my answers to I and I. So moving on to question C. I am asked to show that f dash of x equals this fraction, so I need to differentiate this function, which we can do using the quotient rule or the product rule if we take the denominator and raise it to the numerator and change its sign to negative 0.3x. This is what I've done here. I've just changed the function a little bit. I've taken the denominator e to the power of 0.3x and I've raised it to the numerator and switched its sign. So I have two terms, u and v. There is my u, 20x, and there is my v, e to the power of negative 0.3x. So u v dash plus v times u dash. So this is the derivative of the first term. This is my u dash, and this is the derivative of the second term. This is my v dash, and this entire equation in green is uv dash plus vu dash, which is the product rule. Next, I've done some algebra to try to reach their required form. So I've taken out e to the negative 0.3x as a common factor, and what remained in the first term is the 20x and the negative 0.3, and I can multiply those to get negative 6x. As for the second term, what remains is the 20, so I just leave it as it is. Finally, I'll take this e to the power of negative 0.3x and return it to the denominator and return the sign of the power to positive, hence reaching the required show that expression. Finally, I need to find the interval where the rate of change of f is increasing, and I'll use the GDC to do that, bearing in mind that the rate of change of f is f dash, so I just need to know where f dash is increasing, so I'll sketch it on the GDC. So I've written down f dash on the calculator, 20 minus 6x over e to the power of 0.3x. I've left the x minimum and x maximum in my window as they are because they were provided in the question, but I have changed the y minimum and y maximum a little bit, and I'm going to click on trace to see the graph of the function. Obviously, the graph is increasing starting this point and onwards. So before this point, in this region, the graph is decreasing. After the minimum point in this region, the graph is increasing. Hence, my interval starts at the minimum point and ends at the end of the graph, which is 20, because this is the given end of the graph. Hence, I need to find the minimum point, which I shall do now. So second, trace minimum left bound. So I'll drag the cursor to the left of my minimum. Right bound, so I'll drag the cursor to the right of my minimum. And guess, so there is roughly where the minimum is expected to be. The calculator tells me the minimum occurs at 6.666 or 6.67. So I know that the function is increasing starting 6.67 and ending at 20, and this is my required interval right there. So this concludes our question and this video. Take a minute to write this down if you will. I hope you have found this useful.